At the end of the topic, you will be able to define moment of force, identify couple.
Let us take a rigid body, say, a thin sheet of cardboard. When the cardboard is pushed, it moves in a straight line. Thus, we can say that force applied on a rigid body produces linear motion. On fixing the cardboard at one end and applying the same force will now make the cardboard rotate about the fixed point. Thus, on a rigid body that is fixed, the same force will produce a turning effect about that fixed point. This turning effect produced on a rigid body about a fixed point when a force is applied is called moment of a force or torque. To understand moment of force clearly, let us take the opening of door as an example. A door is fixed at the corner on the hinges and is free to rotate about the hinges. The force applied produces a turning effect on the door about the hinges. On opening the door, the point of application of the force is in the handle and it is far away from the fixed point. The force applied is perpendicular to the line joining the hinges at the point of application of the force, that is, the handle. We can define moment of a force as a product of the magnitude of the force and the perpendicular distance from the point of application of the force to the fixed point about which the body will turn. Moment of force is equal to force into perpendicular distance. What is the unit of the moment of force? We know that moment of force is equal to the force into perpendicular distance. The unit of moment of force in SI unit is Newton meter. In CGS unit, it is dyne centimeter. Moment is a vector quantity. Let us discuss a special type of moment, that is, a couple. Can you identify the forces that come into play when opening or closing a water tap, turning the steering of a car, and the handle of the cycle bar? While opening a water tap, we apply two forces on its top, one with the thumb and the other with the forefinger. So, there are two forces acting on the same object. The two forces are applied in the opposite directions along parallel lines, so that they help each other in producing a turn effect or moment in the same direction. These two forces are equal in magnitude and do not have the same line of action. Thus, a couple is a pair of equal, unlike, parallel forces which, acting on a rigid body at different points, produces a turning effect in the same direction.
In this topic, you have learned force that tends to move a body in the direction of the application of a force and to rotate the body about any axis which does not intersect the line of action of the force and also not parallel to it is called turning effect of a force or moment of the force about the given axis. The magnitude of the moment of force F about a point is defined as the product of the magnitude of force and the perpendicular distance of the point from the line of action of the force. The unit of moment of the force is Newton meter. A couple is a pair of equal, unlike parallel forces which act on a rigid body at different points produces turning effect in the same direction. At the end of the topic, you will be able to narrate the history behind the discovery of the gravitational force, define the effect of gravitational force on objects, explain that a freely falling body experiences acceleration due to gravity, differentiate mass and weight of a body.
It is difficult to say what gravity is. However, we can describe how it works. Relate how all the objects in the universe are under the influence of the same force. Isaac Newton realized that the motion of a falling apple and the motion of the moon were both actually the same motion caused by the same force, the gravitational force. Newton's law of gravitation. Newton's idea was that gravity was the universal force acting between any two objects. From the animation, we will learn more about the Newton's law of gravitation. The universal gravitational constant, G. The gravitational force F is the force of attraction between two particles of masses m1 and m2 separated by a distance r. Thus, F is directly proportional to m1, m2 by r squared. On replacing the proportionality sign, we get F is equal to G m1 m2 by r squared, where G is the universal gravitational constant. On rearranging the terms, we get G is equal to Fr squared by m1 m2. We could further define G to be equal to the gravitational force of attraction F exerted between the objects that have unit masses and are separated by unit distance. The unit of force is Newton, and the unit of distance r is meter, and the unit of mass is kilogram. Substituting these, we get the unit of the universal gravitational constant G as Newton meter squared per kilogram squared. The value of the universal gravitational constant G is found experimentally. The numerical value of G is 6.67 into 10 power minus 11. Newton meter square per kilogram square everywhere. Mass is the quantity of matter contained in a body. It is an inherent and fundamental property of the body. Mass is a property of an object that measures how much it resists accelerating. An object is difficult to accelerate because it has mass. Mass is independent of external factors like position and surroundings. Mass of a given body will be same at the equator as well as at the poles of the Earth or anywhere in the universe. Weight is a force, an interaction between two objects involving a push or a pull. One of these objects is typically very big, the Earth or the Moon, for instance. The weight of a body on the Earth is defined as the force with which it is attracted by the Earth. The weight W of a body of mass m on the surface of the Earth is W is equal to mg. Now let us discuss the concept of weight, its units, and its dependent quantities. Weight is the force of gravity on an object, W is equal to mg. The unit of weight is Newton or kilogram meter per second square. Weight of an object depends on gravity, while the body mass is always the same anywhere in the universe. Let us learn more about mass in the following slides. Now we can differentiate mass and weight. Mass is the amount of matter present in a body. Mass is a fundamental quantity. Unit of mass is kilogram. Mass of a body is measured using a beam balance. Mass is a scalar quantity. Mass of a body remains the same anywhere in the universe. Weight is a gravitational force acting on a body. It is a derived quantity and its unit is kilogram weight or Newton. It is measured using a spring balance. It is a vector quantity and it changes from place to place depending on the gravitational pull of the Earth. Galileo was the first to state that all bodies at rest fall at the same velocity regardless of their material, weight and volume. He dropped objects of different masses and sizes from the Leaning Tower of Pisa from the same height, all reached the ground at the same time. This was due to the fact that the air resistance is negligible in both the balls. Acceleration due to gravity, g. Let us look into the acceleration produced in a freely falling body. The uniform acceleration that a freely falling body experiences due to the gravitational pull of the Earth is known as acceleration due to gravity and is denoted by g. In other words, when an object is dropped from a height, it experiences uniform acceleration by the gravitational pull of the Earth. The acceleration does not depend on the mass of the object which is falling. The force of gravity on m is by definition its weight. Thus, the gravitational force on the apple equals the apple's weight, mg, where g is equal to 9.8 meter per second squared. We know by Newton's law of universal gravitation, F is equal to gmm by r square. Equating both the equations and cancelling terms, we get g is equal to gm by r squared. Thus, value of acceleration due to gravity g is independent of the value of the mass m of the body, that is feather or coin or stone.
From the expression g is equal to gm by r square, the mass of the Earth can be calculated as follows. M is equal to gr square by g. M is equal to 9.8 into 6.38 into 10 power 6, the whole squared by 6.67 into 10 power minus 11. M is equal to 5.98 into 10 power 24 kg.
In this topic, you have learnt that Newton's law of gravitation describes the attraction between all bodies in the universe. According to this law, every body in the universe attracts every other body with a force which is directly proportional to the product of their masses and is inversely proportional to the square of the distance between them. Therefore, F is equal to g m1 m2 by r square. The value of the universal gravitation constant g is 6.67 into 10 to the power minus 11 Newton meter squared per kilogram squared everywhere. The acceleration produced in a freely falling body due to gravitational pull of the Earth is called acceleration due to gravity. Acceleration of a body towards the Earth, g, is inversely proportional to the square of the distance of the body from the center of the Earth, that is r. That is, g is equal to gm by r squared. The mass of a body m is the quantity of matter contained in it, and its value is the same anywhere in the universe. The weight mg of a body is the force with which it is attracted by the Earth towards its center. Its value varies with its location on the Earth, its height from the Earth, and its depth.
At the end of the topic, you will be able to list down the achievements of Chandrayaan, know the achievements of ISRO, understand about space station and its uses. Earth has only one moon. Many nations set out their mission to get useful information about the moon geological details, to know the minerals and chemicals from moon's surface, to study about the evolution and the life of moon. The main objective was to upgrade and test India's technological ability. This was achieved with successful mission of Chandrayaan I, and this led to further research and exploration for future scientists. Chandrayaan is also known as moon vehicle. In Sanskrit, the language of ancient India, Chandrayaan means moon craft. This is the first mission to the moon by the India's National Space Agency, Indian Space Research Organization. The spacecraft was launched on 22nd October 2008 from Satish Dhawan Space Center, Sriharikota, Andhra Pradesh at 6.23 IST. The vehicle was successfully inserted into the lunar orbit on November 8, 2008. Chandrayaan I, the first lunar mission of ISRO, is the beginning. It is aimed at high-resolution remote sensing of the moon. This unmanned lunar exploration mission includes a lunar orbiter and an impactor. The spacecraft is cuboid in shape and accommodates 11 science payloads, and has stabilized spacecrafts using 2 star sensors, gyros, and 4 reaction wheels. Payloads are instruments for experiments from International Space Organization. Chandrayaan I carried 5 ISRO payloads and 6 payloads from other space agencies including NASA, European Space Agencies, and the Bulgarian Aerospace Agency, which were carried free of cost. Chandrayaan I is the first unmanned mission to the moon. It took 21 days to reach the final lunar orbit. India's moon mission is successful. The following are its achievements. Click the next button to view the achievements. Chandrayaan mission took 312 days and achieved 95% of its planned objectives. The Bulgarian payload called Radiation Dose Monitor, RADOM, was activated on the day of launch itself and worked till the mission end. It detected the presence of water molecules on lunar soil. Chandrayaan's moon mineralogy mapper confirmed that moon was once completely molten. European Space Agency payload Chandrayaan I imaging X-ray spectrometer detected more than 24 weak solar flares during this mission. The terrain mapping camera on board Chandrayaan I has taken pictures of the landing site of US spacecraft Apollo 15 and Apollo 11. It also acquired images of peaks and craters. The moon consists of mostly of craters. It also found large caves on the lunar surface that can act as human shelter on the moon. The mineralogy mapper also recorded high-resolution spectral data of the mineralogy of the moon. Lunar Laser Ranging Instrument covered both the lunar poles and additional lunar region of interest. The CIXS X-ray camera also picked signatures of aluminium, magnesium and silicon. More than 40,000 images have been transmitted by Chandrayaan camera in 75 days. Chandrayaan beamed back its first images of the Earth in its entirety. In this topic, you have learned cryogenics is a science of very low temperature within the range of 100 Kelvin, minus 173 degrees Celsius, and absolute 0 Kelvin, or minus 273 Kelvin. Substances that have their boiling point within the required temperature range are called cryogens. Some examples of cryogenic fuels are liquefied natural gas, liquid oxygen, and liquid nitrogen. Cryogenics is used in a variety of disciplines like basic science, biological and medical science, food processing space studies, rocketry, electronics, engineering, and manufacturing practices. The longest-serving space station was the Soviet Mir. On 20th February 1986, Russian scientists set up the Mir space station. Mir was built in stages. It weighed 125 tons and had 6 docking ports and 2 living rooms, plus a bathroom and 2 individual cabins. There is neither up nor a down in a space station. But Mir had carpets on the floor, pictures on the wall, and lights on the ceiling. Mir is a multi-modular station which is capable of keeping 6 spacecrafts within it. On 13th March 1986, 2 Russian astronauts traveled by Soyuz T-15 and joined Mir. People throughout the world enjoyed its live telecast. In this topic, you have learned Chandrayaan I is the first unmanned mission to the moon. The spacecraft is cuboid in shape and accommodates 11 science payloads. The main objective of this mission was to upgrade and test India's technological ability, which was successfully proved in the mission. Space station is an artificial structure designed for humans to live and work in outer space for a period of time. At the end of the topic, you will be able to identify the science behind the cryogenic technique, list some of the practical applications of the cryogenics technique. Cryogenics is a science of very low temperature within the range of 100 Kelvin, minus 173 degrees Celsius, and absolute 0 Kelvin, or minus 273 Kelvin. Looking into history, the word cryogenics is derived from Greek. The word cryos and genes in Greek means icy cold and born respectively. Cryogenic deals with temperature well below minus 150 degrees Celsius, 123 Kelvin. Cryogenics mainly involve production and utilization of low temperature and the behavior of the materials at those temperatures. Substances that have their boiling point within the required temperature range are called cryogens. Some of the cryogens or cryogenic liquids or cryogenic fuels are liquefied natural gas, liquid oxygen, liquid nitrogen, etc. Among these, liquid nitrogen is the most practical cryogenic liquid used for many applications and can be purchased legally across the world. Liquid helium is commonly used and allows reaching the lowest attainable temperature, but however it is very expensive. Thus, cryogenic liquids are held in special containers called Dewar flasks, which are generally about 6 feet tall and 3 feet in diameter. Cryogenics cater to a variety of disciplines like basic science, biological and medical science, food processing, space studies, rocketry, electronics, engineering, and manufacturing practices. The field of cryogenics advanced during the World War II. Scientists found that metals frozen to low temperature showed more resistance to wear. This is known as cryogenic hardening. The commercial cryogenic processing industry was founded in 1966 by Ed Bush and merged several small companies later to form oldest commercial cryogenic company in the world. They originally experimented with the possibility of increasing the life of metal tools. Cryogens like liquid nitrogen are further used for specially chilling and freezing applications. Let us look into some of the applications of cryogenic technique. Rocket. Cryogenic plays an important role in the space industry. The space launching system in the space vehicle used the cryogenic propellants, namely liquid hydrogen, as a rocket fuel. Power transmission in big cities. Since the cables run along the cities, it is difficult to transmit power by overhead cables in cities. But when using underground cables, they get heated. This increases the resistance of the wire, leading to wastage of power. Thus, liquefied gases are sprayed on the cables to keep them cool and to reduce their resistance. Food freezing. For quick instant freezing of perishable foods like fish, chicken, prawns, mushroom, liquid nitrogen are sprayed on them to efficiently preserve them. There is no loss of nutrition and flavor. This is ideal for very large quantity of food that must be stored and exported and distributed in war fields, earthquake-hit regions, etc. Vaccines. The freezing of biotechnology products like vaccines require nitrogen freezing systems. Magnetic resonance imaging, MRI. MRI is used to scan inner organs of human body using intense magnetic field with a temperature as low as 4 Kelvin. A magnetic field is generated by superconducting coils with the help of liquid helium to obtain this low temperature. High-resolution images are obtained at this low temperature. In this topic, you have learned cryogenics is a science of very low temperature within the range of 100 Kelvin, minus 173 degrees Celsius, and absolute 0 Kelvin, or minus 273 Kelvin. Substances that have their boiling point within the required temperature range are called cryogens. Some examples of cryogenic fuels are liquefied natural gas, liquid